Whoa! Watch out, guys. This is very dangerous weather out here. It's why we sent you home early today. Just kidding. It's pretty nice and sunny out. You can see the sky. Yay. Nice and sunny. But this is what we're going to talk about for Chapter 7, looking at weather, climate, and how that shapes biomes and ecosystems. Welcome, scholars, to Climate and Terrestrial Biodiversity, the key components to Chapter 7. If you take a look at the case study in your book today, we're looking at the connections between wind, climates, and biomes. And wind itself is basically just an indirect form of solar energy. Because that sun hits the earth, it heats the air temperature in certain areas more than so in others, and creates for this wind or this movement of basically air to cause wind. And that's basically why we call it the indirect form of solar energy, because solar energy is what's driving those air currents to heat up and then to move. And that's really what it all boils down to. Also with circulation, this wind also circulates, and it circulates not only winds, but also brings with it heat, moisture, plant nutrients, like in our nutrient cycles we just talked about in the last chapter. It even moves soil particles from point A to point B, and even long-lived air pollutants, which can be a bad thing, and keep them in our atmosphere. So that's the kind of the connection between wind and climate, and a little bit on biomes. We're going to investigate that a little bit further with this chapter. This is just an image showing you that this is one of the effects of wind and movement of air masses, because this is showing you dust blown off of basically a desert in Africa and moving towards the Amazonian rainforest. This is dust that can come down, it can stay in the atmosphere, but it probably will eventually come down when it rains, but that rain brings those particles out of the atmosphere. All right, so what factors, this is our question today, 7.1, what factors influence climate? And we're going to answer that question. What are the things that really impact the climate of a specific area or ecosystem? And the first one, again, is what is the difference between weather and climate? Well, weather is the here and now, what's changing. Like my intro said today, you never know what's going to happen in North Carolina. It could be a tornado, could be a hurricane, could be bright and sunny, could be 80, could be cold, who knows? Weather is always changing. But climate is something that is usually shaped by a relative weather pattern. And climate is kind of the long term, while weather is kind of the short term. Air circulation in the lower atmosphere is due to a couple of different things. First of all, the uneven heating of the Earth's surface by the sun. That generates the warmer air masses, which then move because they are warmer from where the warm air rises and kind of rises up. So there's a little bit there. Also, the rotation of the Earth on its axis causes those wind patterns of those warmer areas of atmosphere to move and kind of rotate around as well, and move some of that, as well as the properties of just air, water, and land themselves to allow for that circulation to move those air masses about the world. One of those things, Earth has many different climates because of currents. And there's a couple that we talk about here. One of them is prevailing winds, winds that are coming on a regular basis. It's basically what prevailing winds mean. They're always coming on a regular basis. And a lot of those are driven by Earth's rotation. As the Earth rotates on its axis, it causes those winds to kind of go in a certain formation. It also redistributes heat from the sun within those air currents, bringing those sun, not just on the equator, so everyone's really hot at the equator. It's bringing those air masses and those warmer temperatures to areas around the world, especially in the northern latitudes and the southern latitudes. Link between air circulation, ocean currents, and biomes. Because we have air circulation, we also have that wind is brought across from the ocean as well. We have ocean currents, and all those really the water temperature, the air temperature, all causes the different shapes and different kinds of biomes. You can see this is one of our images from your textbook today. It says natural capital generalized map of the Earth's climate zones. Well, you can see all the different Earth climate zones. We have warm, temperate. Over here, that's where we're at. We have very dry, kind of like over here in the United States and kind of the western part of the United States. We have subarctic up here and way up in Canada and in northern Asia. We have cool temperature or cool temperate, which are kind of up here in the New England area, Michigan, where I'm from. Tropical down in Mexico, South America, Africa, even over in India and China. And we have highland, which is up in the mountains areas, kind of like that the mountainous kind of taiga type forest, and even some major upwelling zones looking at where upwellings occur. Where does nutrients from the bottom of the ocean really come up because of ocean currents and winds causing those things to come up to the surface of the ocean. So we also have a couple things on our map here. Rivers, you can kind of see those throughout the course of the continents, as well as warm ocean currents in red. Right here is an example, and then cold ocean currents in blue. Now, one thing I always ask students to look at when we're looking at this is take a look at what kind of shapes those movements. Or is there any trends that you see? So take a second, see if there's any trends that you see just on this image. Okay, hopefully you guys saw that obviously there in some parts of the earth there are moving in a counterclockwise fashion in the southern hemisphere and sort of like a clockwise fashion in the northern hemisphere. And you can kind of see that going this direction. That we're going to talk about why that is in a few minutes, but it's because of the Earth's rotation is a big one. That's why it's as it rotates, and the sun is directly heating at the point of the equator, so that's where it's heating, and it kind of moves and spins off that way because of a certain effect called the Coriolis effect, and we'll talk about that in a little bit as well. Also, some of these areas, if you notice in the blue, this is all cold water. So when those cold waters, those are usually deep. Cold water is very deep. Very salty, dense water, cold, just like hot air rises, cold air says the bottom. Same thing with the ocean. So cold waters are more deep, and warm waters are more in the upper part of the water column. And so you can take a look at this. If you notice that wherever those cold currents actually hit a landmass, and there's some upwelling here. This is a good example. That also, as that upwelling occurs, that water has to come up to the surface, and when it comes up to the surface, it obviously turns into a warmer current. So that's kind of where those two meet, and that's also, if you notice, also where some of these areas where hurricanes form, those cold and warm air masses, kind of an interesting topic there. This is another image here that I want to talk about today, and then your book doesn't mention this, but there are 3 different types of cells. We call them convection cells, and that's what these are located right here. Those are called convection cells. I'm going to tell you the names because they might come up on the AP exam, but the first one and the most strongest of them all, because of where the sun is at the equator, are these two. Those are called Hadley cells. Hadley cells are the strongest. They're kind of like, if you ever look at the inside of how a watch works, they kind of remind me of the gears moving each other. That's why a lot of times you see this one's moving in a counterclockwise fashion, this one's moving in a clockwise fashion. They're literally working like gears, moving in and kind of moving themselves. But they're all really driven by solar energy. And so that is kind of how the wind currents move. That's kind of how a lot of our water currents move as well, in these kind of convection cell-like fashions. And so this is kind of, we'll talk about more about the breakdown. We'll take a closer look at that part of the convection cell in a little bit. We'll take a look at the cross-section of it and really talk about why these cells actually occur. But if you notice, back to our previous image here, I want you to take a look at these arrows and look at which way they're pointing. This is which way obviously the Earth is rotating, the solar energy is coming in, and the wind and the hot air, warm air is kind of moving away from there in those different fashions because of the Earth's rotation. And so you can kind of see that. So this is called the Hadley cell. These two are Hadley cells. These two over here between the 30 and 60 degrees latitude on both sides are called the Ferrel cells. Ferrel, F-E-R-R-E-L. Yeah, do that. F-E-R-R-E-L, sorry. And that's the Ferrel cells. They're less strong, but they are more strong than the last ones we're going to talk about, which obviously, because they're located at the poles right here and right here, are called the polar cells. So those are our 3 major types of convection cells that are really moving air currents throughout the entire Earth. So this is kind of the cross-section of a convection cell. And so we're kind of talking about it here today. We're looking at energy transfer and how is that solar energy really transferred through. Well, this is kind of how it works. So if I were to go back and look at just this section right here, I would say that this is what it looks like, the cross-section of it. And so what happens is, the first thing that happens is we'll talk about where the air is at. We'll start at the bottom. So it's warm and dry air. Well, as it moves across the surface, it's warmed by the sun, and it's a very moist surface, being the oceans. Okay, most of it is picked up, the moisture is picked up, and it becomes hot, wet air, and that's at a low pressure system. So it's move across the surface, moist surface, picks up water, and actually because it's warmer and it's getting hot, it's going to rise. That's what warm air rises. You heard that before probably when they talk about farts. someone farts, hit the deck because warm air rises. Anyway, that's too much information, TMI. But anyway, the hot, wet air actually rises up, and then it condenses, and it gets to high pressure, rises, expands, and then cools because it's further away from the earth, and it actually cools down, and then it condenses, and precipitation occurs, rainfall, that kind of stuff. Well, some of that heat is actually released out into space. Some of it is then moved and kind of circulate a little bit, and then it becomes cool, drier. Once it loses its moisture, it becomes dry, also stays cool. Well, then that cool air again falls to the bottom, right? Cool air kind of drops down, and it falls, compresses, then warms again by the earth, absorbing the heat from the earth, and then it goes through all again. But that is how a convection cell works, and that happens in all three, well, 6 if you count 2s in each, the Hadley, Ferrel, and polar cells. So another look at just another picture of connecting deep and shallow ocean currents, looking at how those move through. Again, what's causing, if you look at all these currents, if you get one thing away from this picture, take a look and look at what is causing the upwelling or the rising, and what is causing the changing, not of really of direction, as well as the elevation of the current. So most of it comes from the continents. So if you look at this is driving, it's going, it gets all the way to here where there's continents, and it obviously deflects off of those, moves in a kind of a fashion that is in the same direction as the rotation of the Earth, as well as it brings to the surface, so it becomes warmer, and then it goes through it again. So if you look at all those different areas, I'm not going to point out each one of them, but if you look at each part of that, that's exactly how it works as far as the ocean currents go. So we talked about the Hadley, the Ferrel, and the polar cells. Well, these also, those circulations of warm and cold air masses automatically relate to the different types of climates and biomes that we have. And this is a great picture that talks about that. If you take a look at where the sun is entering, obviously at 0 degrees or the equator, as your tropical rainforest, you're actually having a lot of drop and a lot of rainfall, precipitation occurring there. Well, as it goes further this way, let's go on we're going north latitudes this time. As the air circulates, and it's a big circulation, it's not just a small little area like over the town of Jacksonville, it's huge, huge air masses. As it moves this direction, kind of towards or away from the equator, it becomes more dry because it's already lost all of its moisture content. So now it's cool, dry air, and then eventually it sinks down. As it sinks down, it actually brings heat with it, and those areas, those dry areas, you can see are the deserts. Where the area of high precipitation is are your dense, thick forests with vegetation like the rainforest, the evergreen coniferous forest on both sides. Taking that's exactly how it works. Is just looking at moisture, how that relates to the dry air masses, and looking at where those convection cells are moving. So in between the cells are deserts. That's a key feature to know, and where kind of where that moisture or the precipitation is coming down within those cells is where you have your big thick forest. So and when you're not doing that, you're kind of somewhere in between, like the temperate deciduous forest down here in the southern hemisphere. So that's just a quick look at global air circulation, how it relates to climates and biomes. All right, so greenhouse gases, warming the lower atmosphere. These are kind of key to holding in our warmth that the sun is giving us. And our major greenhouse gases, which one of them is kind of weird, it's water. Water is a greenhouse gas. CO2 is your most highly known one, but water actually is probably a greater known greenhouse gas than CO2. Even, well, not actually greater known, but greater greenhouse gas does a bigger job. But CO2 is becoming more popular because of our impact with CO2 in the atmosphere. CH4 is methane gas, kind of stuff out when you fart and when cows belch. And actually, that's kind of a big contributor to methane in the atmosphere, our cow farms and cattle farms, as well as our decomposition from our landfills. And then nitrogen oxide is another greenhouse gas that, not as important, but still is given off when we're burning nitrogen or releasing it through our combustion process of our fossil fuels. Greenhouse effect is a good thing. It holds in the warm temperatures that are given to us, the warm energy given to us by the sun, and it's very, very vital for keeping our atmospheric temperature on our Earth relatively stable, not really going from super highs to super lows like some planets. So that is what is really, really key. It's a good thing. Now, human-enhanced global warming is different. It's kind of enhanced greenhouse effect, like super enhanced greenhouse effects, because we're increasing CO2 and methane gas, causing for greater greenhouse effect, which ends up warming our Earth too much, which is kind of what a big scare is. And here's a picture of it. I think we've talked about this before, but just to kind of reiteration, looking at solar radiation coming in, the greenhouse effect trapping in those gases, or trapping in that heat because of those gases, causing our Earth to stay at a stable temperature. Excuse me. All right, Earth's surface features affect local climates. So heat absorption by land and water. So looking at the effects of mountains. Mountain ranges are huge. They actually provide this thing called a rain shadow effect, which I'm going to explain very clearly when we take a look at this next picture. So when you look at the rain shadow effect, this is, picture the West Coast, California, right? California. Anyway, stupid song. But if you take a look at this, we're looking at the wind and the moisture bringing it. So we have prevailing winds coming from, always from the west to the east usually, across the United States, which is why sometimes flights are cheaper going from west to east because they use less gas. So just an interesting fact for you. Prevailing winds pick up moisture from the ocean, so they're picking that up, and actually it's cold. It's usually colder. You know, that's why California is not super hot all the time. It actually stays at a pretty decent temperature, more so than even North Carolina. So prevailing winds pick up moisture from the ocean, kind of staying at a cool, very low to the surface. As it picks up moisture, it's forced upward because of the mountain range, which is why this is where we get into the rain shadow effect. It's forced upward from the mountain range, and on the windward side, this is the windward side, good vocabulary to know for the quiz. On the windward side of the mountain range, the air rises, it cools, and then releases the moisture. So it releases the moisture content as the air is rising. It releases all of it. It condenses on the windward side of the mountain, and then as it gets over the top, it's kind of warmed up a little bit, and it's actually not as moisturized because it already dumped all of its moisture over here on the windward side of the mountain. So on the leeward, which is this side of the mountain here, the leeward side of the mountain, it is now warm and very dry. And so if you look at literally the United States, you look at California, there's the Sierra Nevada mountains right here, and there's lots of rain up in here. And then as you get over top of that, then you have your desert, which is out west, kind of like the Badlands, things like that. So that's exactly how it works, and this is called the rain shadow effect because of prevailing winds and also because of key factor mountain ranges. Now, one thing we skipped over, going back to this slide, is city climates, or cities or microclimates. Now, I'm going to tell you my quick story about Vegas. Now, Vegas is fun, but not really for me. I'm more of a nature guy. So what I did learn in Vegas, what I took away from Vegas, other than the stuff I learned at my awesome teacher conference that White Oak sent me to, was that Vegas stays hot all the time. So I'm used to at night, even in North Carolina, it cooling down a little bit, right? The sun's gone, cools down, awesome. Well, when you're out in Vegas at night, which you'll eventually experience someday probably, it stays hot because of the fact that so much concrete is used in Vegas. Concrete is a great holder for heat. So if you think about it, if you're out on your asphalt on a hot day and you walk out there and your feet start burning, it's because the concrete's a great absorbent of heat. So what happens is all that heat is trapped in all day long, absorbed by the concrete. Well, at night, it's then released because there's no more sun. So all the buildings radiate heat off of them, and so all of your air masses or your breezes that come through, Las Vegas, are very warm. It almost made me puke because I was so used to just having cool breezes coming through all the time, even at night, even in North Carolina, that I was like overwhelmed by hot air blowing on me. It made me feel nauseous, which was really gross. But that was my one memory of Vegas, just because it was just something that had to do with what I'm teaching. All right. So climates affect where organisms can live. Obviously, we talk about climates a lot in this section. Major biomes are formed because of weather and climate, and latitude and elevation changes, annual precipitation, and temperature. All those things affect where the organism can survive. Remember, we're talking about some of those abiotic factors in our zone of tolerance and our zone of intolerance and those kind of things, looking at the tolerance of organisms. Well, temperature and precipitation are huge in that. And also elevation as well. The pressure that organisms are put under, as far as barometric pressure, has a lot to do with where they can survive too. So those are some of the things that affect where organisms live, and all are based into this big category that we call climate. Hopefully you've enjoyed 7.1. We'll see you later on 7.2.